So our learning goal over here states, we as just said, we can already solve algebraic equations, already know how to do that. But what do we do when we have fraction coefficients? And remember what coefficients means? What's a coefficient? Where is the coefficient located? Is that what you think you know?
The number x is being multiplied.
Yeah, the number x is being multiplied by. Good. The number x is being multiplied by. So if it's not an integer, maybe sometimes it's going to be a fraction. And how are we going to handle that when we have a fraction coefficient? Okay, so let's take a look at this first problem here where we have Kara and Micah. That's how I'm going to go. I don't know if it's Mika or Micah. Should we go with Micah?
It's Mika.
It's Mika? Okay, we'll go Mika then. Okay, Kara and Mika are practicing throwing a frisbee. Kara is just learning, so she's not that good at it yet. Kara can only throw the frisbee half as far as Mika. When the distances they throw are added, the total distance is 45 yards. How far can Mika throw a frisbee? How far can Kara throw a frisbee? What's the first thing we always do? Circle the questions. What are they asking us to find? So, yep, so we need to know how far Mika can, and we need to know how far Kara can. So how many answers should there be? Two. We need 2 answers when we're all done here. So let's just kind of get a little setup started here. We got Mika, and we've got Kara. Okay, now let's go through the problem and decide what can we cross out, what should we underline, what do you think we need, don't need. Somebody give me something? Sierra?
Kara can only throw the first 2.5 as far as Mika.
Okay, is that something important I should underline or should I cross that out? That's probably important. Kara can only throw the frisbee. I'm not going to try and underline that half. I'll just half as far as Mika. That's probably important information, right? Okay. What else? What are we going to do? Other important information or information that really doesn't matter in the realm of solving this? Danny? The first sentence doesn't matter. They're practicing throwing a frisbee. Okay, that really doesn't matter. Sam?
The second sentence
The second sentence doesn't
doesn't matter.
matter. Okay. What else? Anything else we should do? Sylvia?
You should underline the total equals 45.
Okay, the total distance is 45 yards. Maybe we'll put a box around that because it's kind of hard to even see in here what's going on. Okay. Okay, that pretty much takes care of everything, doesn't it? Okay, well, so now we kind of, remember we always have to decide what's the main character in this so we can give that the variable. What's the main character, do you think? Is it Mika's distance she can throw it, or is it Kara's distance she can throw it? Kara's the main character? I think Mika is. It says Kara can only throw the frisbee half as far as Mika. Don't we need to know how far Mika can throw it? So isn't Mika's the main, isn't her distance the main character in this? So Mika's is x, and Kara's would be what then? 1/2 x. Kara can throw it half as far as Mika can. Okay. Now, what can we do with that to set up an equation? Danny?
X plus 1/2 x.
Okay. We need more, right? Equals 45. Okay. There's our setup. X plus 1/2 x equals 45. Okay, let's go to that work page and let's write that equation on that work page. Okay, so here's our frisbee problem. We have x plus 1/2 x equals 45. I'm gonna take a moment and just calibrate my board here because it's not cooperating with me real well. See if you can decide, can we go right to work solving that, or do we need to do something to it first to get it ready to solve? Is it ready to solve? Remember, solving is when you can start doing the same thing on both sides. Is it ready to solve? Or are there some things we can do to it first? Sammy? We can combine our x's, can't we? Yeah. But to combine our x's, this looks like, on that assignment that I asked you to keep up, does this look like the bottom part of that assignment? Part 2 of that assignment, activity 2? It sure does, doesn't it? Okay, so what are we going to have to do? Harley?
We're going to put x over x and have it equal to the denominator.
Well, we can't put x over x because you can't just put something over itself.
X over 1.
You can put it over 1 though, okay? So is there really a 1 here in front of this x, you guys? Let's stick one there. There's an invisible 1 there, right? So this is like our whole number part. So what we need to do is we need to rename this 1. So let's go over here and do that. We have 1 over 1. Remember, we didn't do anything with those x's, did we? Didn't we leave them alone while we were renaming the coefficient? So we're going to rename the coefficient 1. So we'll put it over 1. And what do we want it to become? Halves, right? Okay, so we need it to become halves. So we're going to multiply both upstairs and downstairs by 2. And what's its new name, that one? 2 halves, 2 over 2, right? So now we take that new name that we have for 1 and put it in front of the x. And we write the rest of the equation with it. Because now we can combine like terms, can't we? What's 2 halves x plus a half x? 3 halves x. We have 3 over 2x. Okay. Is it ready to solve now? Anything else we should do to it before we start doing stuff on both sides? No, I don't think so. Yeah. So what are we going to do to both sides is the question. We need that to become a 1 in front of that x. But this is a fraction. So instead of dividing, we're going to multiply by its reciprocal. So what's the reciprocal of 3 halves? 2/3. So we're going to take this side times 2/3, because remember, a number times its reciprocal gives us 1, and that's what we want, is a 1. If we do that over there, we have to do it over on this other side. But that 45 on the other side is not a fraction. Can we make it into a fraction?
Yeah.
By doing what? Putting it over 1. Okay, over here, it's kind of like when we divide by something, when we add the opposite of something, we end up with what we want. So it's kind of like this x is now all by itself. These guys take care of each other. We end up with a positive 1 over there. Okay. Now we're going to multiply and divide. So what's the first thing we got to do? We got to take 2 times 45. What is it, Harley? 90? Okay. You all agree with her? Yeah, okay. So we end up with a 90 upstairs. And 3 times 1 downstairs is 3. And now we're going to have to do 90 divided by 3. 30 goes in, 3 goes into 9 3 times. And so I end up with 30 for that. So So I can say that x equals 30. So who's this again, Kara or Mika? Now we're Micah, huh? This is Mika, so let's just do that for right now. We're gonna go write sentences back on our other paper, okay? That's Mika. Well, if that's Mika, we got to figure out what Kara's is yet, don't we? How are we gonna figure out Kara's? Anybody have any idea how we can get Kara's? Sam? Take half of 30. So let's go over here to the, do you have some white space over here maybe? And let's say Kara, remember, was 1/2 x. So we now know that x is 30, so we're going to take half of 30, which is 30 over 2, which is how much? 15. So this is Kara. And then before we write our sentences, let's see if this seems reasonable. 30 is what Mika can throw it. 15 is what Kara can throw it. And what were these measured in? 30 what and 15 what? Yards. Okay. So if we added them together, what would we get? 45. So do we seem to have a good answer? Yeah. Okay. So let's go back to the page where the problems were on. And let's write sentences. Mika can throw 30 yards. Remember, we don't do any abbreviating sentences. You get to write the numbers off. Mika can throw 30 yards, and Kara can throw 15 yards. Okay, so what was the only thing that was really different today? Those fractions, we had a fraction coefficient in our equation after we got it ready to solve. We had that fraction 3/2. And how did we take care of that? How did we deal with that fraction coefficient once we were solving? Go back to your work page and look. What did we do to solve the equation with the fraction coefficient? Do we divide? Read, please. Engage. What did we do? Did we divide? No, we multiplied. What did we multiply by? What's that called? The reciprocal. We multiplied by the reciprocal. Okay. Let's go to number 2. We have barbells being used in a gym for heavy lifting, and they come in different weights. The first barbell, well, they have a picture here. Let's just use it. Is 1/3 the weight of the second barbell plus 25 pounds. The combined weight of the 2 barbells is 225 pounds. How much does each barbell weigh? What are we gonna do first? What are we gonna? I love how you guys just do it. Go ahead, just do it. Underline, circle, cross out. Get yourself ready to solve this problem. And then decide which of those 2 barbells, the first one on the left or the second one on the right, is the main player. Which one is the main player, the main character? The first barbell's weight or the second barbell's weight? The what? The second? How many of you want to agree with Danny it's the second barbell that's the main player? Yeah, I agree. So we're gonna say this one is X. Well then, what would we write for an expression for the first barbell's weight? 1/3 X. It's 1/3 of the weight. Is that enough? Plus 25. There's also got an extra 25 pounds that we gotta add on there. So it's 1/3 of the second barbell's weight plus 25. So what else can we say? That together they add up to what? What do they add up to? 225. Okay, we have an equation there, don't we? 1/3 X plus 25 plus X equals 225. Our picture gives us an equation. Okay, let's go to the practice page then and write that equation down for the barbells. So we have 1/3 X plus 25 plus the second barbell's weight of X, and all together there's 225 pounds of weights. Okay, is this equation ready to solve? No. So what do you think we might want to do first? Tyler? Combine the x's. So let's get them beside each other to start with then, right? So we're going to have 1/3 X plus X, so the X and the 25 are going to trade places. So that's the first thing. Let the X and the 25 trade places. Okay, now what? If we're going to combine them, what are we going to have to do? We're going to combine them, what are we going to have to do? What did we do in the last problem before we combined them? They're not coming for us after. But if you don't answer me pretty soon, I'm going to call them. No. Come on, tell me what do we have to do before we can combine them? Add the x's together, but how are we going to, we can't yet. Danny? No, I don't want to start solving this yet. No, we can't. We're not ready. Harley?
X over 1.
Well, not x over 1, but let's stick a 1 in front of that x. And since that's not a fraction, we're going to make it a fraction, and we want it to be a fraction that's friendly with the other fraction. So let's come over here and let's make it ready to be combined with that other fraction. So what are we going to have to multiply by? Do we want halves, thirds, fourths, fifths, tenths? Thirds. We want thirds. So we're going to multiply top and bottom by 3. So 1 made into a fraction, we put it over 1. We multiply the upstairs and the downstairs by the same thing. And here's the new name for our 1 that's in front of that x. So now we go back to our equation and we replace the 1x with 3/3 x. There must have been a reason that Legrand had you practice that before today. Now we can combine those x's, right? We're finally there. How many x's are there? 4/3. 1 plus 3 makes 4 of them. Now is it ready to solve? Yes, we're finally there. Okay, now, Danny, what would you like us to do? Danny? What was it that you wanted me to do a while ago when I said not yet? Add a negative 25, is that what I'm hearing? Okay, add a negative 25 to both sides because we want that positive 25 to 0 pair out. You will, or you're going to.
She's picking on me. I transposed the numbers, and now she's getting mad at me.
Stop, but this is being recorded right now. Just stop and do what she's asking you. You show that respect. Period. Okay, so.
Attention all students and staff. Our building is going into an administrative lockdown for a student medical issue in the junior high locker area. Please remain in a lockdown until we communicate further. Thank you.
Okay, here we go. We're adding a -25 to both sides. And what did we get, 200 on the other side? Do you agree with me that if we have 225 and we take, okay? So now, what would we do next? There's a fraction coefficient, what are we gonna do? Danny? Okay, what is the reciprocal we're gonna multiply? 3/4, so we're gonna take 3/4 times the 4/3, that creates the 1 we want. If we take that side times 3/4, we have to take the other side times 3/4. Well, that 200 isn't a fraction, so let's make it 1. And now we're gonna have x, like we want. And what's 3 times 200, class? 600. What's 4 times 1? 4. Now what are we gonna do? Divide. Okay, let's figure out how many times 4 goes into 600. You get 150?
Yeah.
So did I. So we're going to say that x equals 150. Which barbell is that? Go back to the picture.
Second one.
This is the second. Okay, so let's just put that there right now so we just have that. That 150 represents the second one. And we'll make our sentences in a little bit. Okay, well now we need to figure out the first, don't we? So let's go over, find some white space that you have left. So the first one. Okay, what was the expression for the first one's weight? 1/3 x plus 25, okay? So we're gonna have to take 1/3 times the 150. That's how much x is. Make it into a fraction. Okay, you figure out what 1/3 of 150 is. What is it, Danny? 50, she says. So in other words, you get 150 over 3 first, don't you? And then that becomes 50. Okay. What do we get? 75 for this one. So let's just make a big circle around that. Okay, do our answers seem reasonable? 150 plus 75, what would that be? 225. Seems like we have some pretty good answers, don't we? Okay, so let's go back to where the word problems are written, and let's write our sentences. Okay. We're not going to use 1ST. We're going to write the word first. The first barbell weighs. How much did we find out it weighs? 75? Okay. 75 what? Pounds, okay. P-O-U-N-D-S. And the second, because we're supposed to have two answers, barbell weighs 150 pounds, okay. Okay, Okay, we got one more we're gonna practice. So we're kind of like trying to learn how to solve equations with fraction and coefficients all along with doing word problems because we're getting so that we're gonna be so good at word problems pretty soon. We're gonna wanna do them. Not here, okay. Trina is 1/4 the age of her grandfather, less 5 years. Their combined ages is 95 years. How old is Trina? How old is her grandfather? Boy, they just cut right to the chase this time, didn't they? Did they give us any extra information? No, thank you guys. Okay, nothing we have to cross out. We have to figure out how old Trina is, how old her grandfather is. We need 2 answers. And everything in that problem is needed, so I'm just not even gonna underline. I'm like, okay, seriously, I need all of that, right? So we have Trina. And we have Grandpa. It's a little shorter than grandfather. Who's the main character? Who's the main player in this one? Who? Grandpa?
Grandpa.
Yeah? Okay, so Grandpa gets to be X. Okay. Well, if Grandpa is X, then what's Trina?
1/4 x plus 5.
1/4 X, take away 5. Okay. Now what? Their combined age is 95 years. Combined means we're going to add, right? And altogether it should be 95. So, can Grandpa be 95? No, at least he's younger than 95. Okay. So, you ready to go to our work page and solve it? I think you gotta go to the back side, right?
Yeah.
Okay. So I gotta skip over 2 pages here. Okay, so we had, Trina was first, so she's 1/4 X, take away 5, plus Grandpa X equals 95. Okay, we're gonna get it ready to solve. What would be the first thing that should be staring you in the face saying, Mrs. LeGrand says, Harley?
X minus 2.
Add the opposite. That's the first thing we're gonna do. 1/4 X plus a negative 5 plus an X equals 95. I'm not even really sure what you said, Harley, but what was it?
Put the x values together.
Okay, now we'll do that. Now we'll put the X values beside each other. So now we'll say, okay, you guys are like terms, so why don't you come together at the same point of the equation. So the negative 5 and the X are trading places, right? Okay, now what? Remember there's an invisible 1 in front of this X. What are we going to do with that?
Put it over 1.
We're going to rename it as 1/1, and then we're going to go even further. We're going to rename it as what kind of fraction? Fourths. We need fourths. So that means we would have to take upstairs and downstairs times 4. So 1 is the same as how many fourths? 4 fourths. Okay. So now we can say 1/4 X. And we're going to take this 1 right here, and we're going to say you get replaced with the 4 fourths. Because now they're friendly. Okay, you do the next step on your own. Decide what you should do. It's not ready to solve, by the way. Okay, what does your equation say? I'm just going to share with you. You taught me, Wade.
5 fourths x plus negative 5 equals 95.
Okay, thank you for sharing. Anybody want to agree with that? Yeah, we all should. He's right. Okay. Anything else we should do, or should we start solving? Is it ready to solve? You always need to ask yourself that question. I know you're annoyed by me, but, okay, here we go. What are we going to do first? Add 5. We need that negative 5 to cancel out, so that its opposite is 5. So we'll add 5. If we add 5 there, we gotta add it over on this side. So now we have that 5/4 x alone. And what do we have on the other side? 100. Okay. Now you decide what's the next step you're gonna do. Fraction coefficient. What have you decided to do? Divide? No. Multiply, right? What are we going to multiply by, class? Okay, what is the reciprocal that we're going to multiply by? 4/5. We're going to multiply 5/4. Its reciprocal is 4/5, so we need that to get that to be a 1x like we want it to be. If we do that on that side, we got to come over here and multiply by that 4/5 on this side also, and make our 100 into a fraction also. Okay, class, what's 4 times 100? 400. Okay, class, what's 5 times 1? 5. Okay, we're going to have to figure out what 400 divided by 5 is. 80? Okay, good job. So that's 80. So we have x equals 80. What's that 80 in this problem? Grandpa. Okay. Well, then we gotta figure out how old Trina is. Let's see, Trina was what again? 1/4 x minus 5. Okay. So we have to take 1/4 times Grandpa's age, he's 80. And then after we do that, we have to subtract that 5. Let's first figure out what's 1/4 of 80. So 80 over 4. And then subtract 5. Oh, sorry. And what's 80 divided by 4? How many 4s are in 80? Split 80 into 4 equal groups. What's in each group? 20. How old is Trina? 15. Oh, that. Does that seem reasonable? Grandpa's 80, Trina's 15. How old were they supposed to be together? 95. Seems reasonable, doesn't it? Okay, let's go back to our word page and write our sentence then, okay? Anybody need this though for a little bit? Would you let me keep it here while you're 1, 2, I gotta go back. Okay, so you start with whoever you want. You just write your sentence. Go ahead, I'm not gonna do it for you. So go back on this page and write your sentence answer, giving their ages. Okay. So, more practice with word problems. Now we know what to do when the coefficient is a fraction. Anybody have questions? Okay, then we'll call this quits.